Hello everyone! Recently I made a video about how macOS uses memory, and in that video we tested what happens when you have an app that is practically misbehaving and using all of your system memory. How does the OS handle that? And it was a lot of fun to test and you guys enjoyed it, so I thought, well then, what about the CPU? Because arguably the story with the CPU is even more complex. We know that we have performance and efficiency cores, but the question is, at which point does the system decide to use each core type? And maybe even more interestingly, is it even willing to use all of them at the same time? And if it does, then for how long before it throttles? And also, what happens when you're running on battery or maybe even in low power mode? How far can you push the system then? And is it willing to give you everything that it has? Coincidentally, I was also working on many different improvements for the system monitoring feature for my app, and while testing it for the very first time, I actually discovered something quite strange, so maybe that's a good place to start. So let me show you what I made. My app allows you to track your system usage right from here. But if you click on any one of these, you can open the full system monitoring dashboard. So here, for example, you can monitor your CPU usage, or here it's memory, but now we have the brand new stats page. And from here you can monitor your temperatures, for example, you can see the breakdown of usage per CPU core, and you can also track the GPU temperature, which admittedly doesn't yet read correctly all of the time, but also the GPU usage, which does. So let me ask you a quiz question. If we run a single threaded program on this machine, what is the chart going to show? Are we going to see just one core working? Is it going to be the performance core or an efficiency core? Or maybe we're going to see something else entirely. Maybe some of you will remember I wrote like a little benchmarking script to test the performance of the M4 and M5 chip in Dino. And the reason Dino is a great choice for this first test is that it's inherently single threaded. And yet, after running the test, we can see that all of the performance cores have been equally activated and virtually no efficiency cores. And another fun thing to observe is that the moment performance cores activate, the temperatures spike. But not only that, it's also the GPU sensor temperatures that are reading much higher values, because after all, this is all on a single chip. But the question remains, why is the Mac activating all of the cores for a single threaded program? So I found something that is very typical Apple. macOS strictly forbids CPU pinning. Apple's kernel engineers removed explicit core binding APIs years ago. They believe the macOS scheduler understands the thermal layout, battery efficiency, and core mapping of Apple Silicon better than any developer. Okay, so even with a single thread, because Apple engineers know best, we've been able to activate all of the performance cores. But the question is, if we had a proper multi-threaded program, would it be possible to activate all of the cores? So I spent some time working on this little test app to try and answer some of these questions. The design is very human. Let me show you. So in this little app, you can create a worker, and the worker simply recomputes this hash over and over again just to keep the CPU a little bit warm. But in order to be able to precisely control the load that we're putting on with these workers, each worker has a slider that controls the duration of the break that the worker takes between each loop of the hashing algorithm. So Apple engineers are controlling the CPU and we're controlling the threads. So what will happen when we start playing around with these workers? So obviously, if the workload is pretty low, like we have here with these two workers taking it easy, we are really only activating the efficiency cores. And then obviously the second option is, even with a single thread, you can pretty much pin all of the performance cores to 100%. But there is a third option. This one I kind of discovered by accident. Okay, it's doing it now, check it out. So for a while I had this workload running on performance cores because this is how it initially started. But without me changing anything at all, it seems like the system decides that this workload can actually run on efficiency cores, and so it just switches over. But if we take a look at the temperatures, it doesn't appear that it was because of some temperature spike. It seems to be just because the system is preserving power. It's almost as if the CPU is doing some kind of real-time discovery. Like, let me run it for a little while on performance cores, see how it works, let me try it on efficiency cores, and if it still works, I'm gonna leave it there. But what if we crank up all of the workers, reduce all of the breaks? Can we activate all of the cores, and for how long can the CPU keep up with that kind of a workload before it starts throttling? So I'm just going to create a few more workers, and actually the moment I did it, it switched over to performance cores entirely. But we can always demand more. And so here, for a good while, we had all of the performance cores working at pretty much 100%. And you can see the temperature was pretty high. I recorded 115 degrees maybe. And then after about 3 minutes or so, it needed to take a little break. And now it's bouncing back and forth right there on what its maximum capability is. And now it's actually done it again. It's pinned the efficiency cores to 100% while the performance cores are getting quite a good break. And you can also notice the exact point that happened by the temperatures that went significantly down. But we still hadn't reached the point where the CPU has to activate all of the cores. So there's only really one solution to that problem, which is called workers. Alright, so the reason we're doing this is because I really want to discover for how long the CPU can sustain an absolute maximum load. Because finally, as you can see, we are activating all of the cores, and it's only a matter of time before it starts throttling. And it honestly didn't take very long at all. So each of these bars is 5 seconds. So it was 1, 2, 3, 4, 5, 6, 7, 8, let's say 20 times 5. So the CPU is willing to use all the cores, but only for a short while, maybe a little over than a minute and a half. But the question I have is, what happens if we run the same thing on the MacBook Air? This is an M5 MacBook Air, and so instead of 8, it has 10 cores, 6 efficiency and 6 super cores. Alright guys, this video is sponsored by Lovable. With Lovable you can build anything you can imagine, and you can take your ideas from concepts to production in just a few prompts. So let me show you what I made. Many of you know that I have this app that I've been working on for a long time. And I've been using my Discord server as a support community as well. So we have bug reports, feature requests, all gathered here. But there's a problem with that. So what is the problem then? Well, my app actually has 11,000 daily active users, and that's more than the total number of members on my Discord server. So clearly not everybody wants to be on Discord, which is understandable, but then the people who are not there, they don't have a place to submit feature requests or bug reports or even ask a simple question. So I decided to use Lovable to build a proper support and customer feedback portal where you can search and filter by type or by status. You can write comments, have a discussion, you can sign in with your Google account, which works immediately, and it's so fascinating to see how with a single prompt I was able to get all of this. What's really amazing about Lovable, you can see the code that's been generated for your app, but you don't have to touch the code in order to make changes. You can select an element and immediately provide your feedback. And what's really great is that it's a fully integrated platform, so you can see everything that has to do with the backend as well. You can inspect the database, you can see the storage, the secrets, the edge functions if you have them. You can read the logs, which is really cool, and it all comes bundled together in a nice and easy to use package. So if you guys have an idea of something you want to build and you just don't have the time to write it up from scratch, check out Lovable using the link in the description, and I'm pretty sure you will be amazed with what it can do. So there are really 2 questions I want to try and answer. Number 1, given that we are running on battery and that we don't have any active cooling, is it even possible to get all 10 cores to be working at the same time? And then secondly, what really happens in low power mode? Alright, so I pretty much gave it all that it has, and would you look at that, it's actually willing to use all of the 10 cores simultaneously. It requires something like 20 workers, but it is pinning all of them. And then at some point, which is about exactly now, it simply had to throttle down because of the temperature, which was getting up to 100 degrees. But overall, really solid performance. I wasn't expecting such a consistent and stable load across all of the cores. So it is willing to use all of the cores even on battery. But what about low power mode? Alright, I am a little bit surprised with what's happening. I thought that it would use only efficiency cores. That was kind of my intuition. I'm curious what you thought, but what is happening actually is something I did not expect. Would you look at this? It's actually using all of the cores, and the performance cores have actually stayed stable at 100% for most of the time. It is now switching. What's interesting is that during the time that we had all 4 performance cores running at full capacity, the temperature wasn't all that high at all. So it seems like the low power mode is just that. Less power to all of the cores. So there you go, we've tested everything. If you enjoyed the video, make sure to like and subscribe, it really helps me a lot. Check out the links in the description, and I will see you in the next one.